Hello, everyone. My name is Andrew, and I'm currently a PhD student at Carnegie Mellon University. Today, I will be giving a tutorial on contrastive learning. So, what exactly is contrastive learning, and how is it different than classification learning or regression learning? Classification learning is basically learning to discriminate. Given an input, you will predict a vector. And the goal of contrastive learning is to learn a system that can put vectors belonging to the same class closer together, while vectors from different classes are pushed farther apart. This is commonly known as metric learning, as you are trying to learn a space where distances or metrics satisfy some constraint. What does that look like in practice? So suppose I have 100 photos of you taken from different times and angles. We call them positive pairs. The goal of contrastive learning is to pull all the vectors corresponding to these images closer together, while if I have 99 photos of a different person and one photo of you, I want to push those 99 vectors away from your vector. So before we train the network, these vectors for the red and green classes are distributed randomly in some space. After training, the green vectors are pushed closer together to other green vectors. The red vectors are pushed closer together to other red vectors, while the green and red vectors are farther apart from each other. And how exactly do we use a network trained using contrastive learning? Well, one way is you can use it directly. Given two photos with unknown subjects, you can now easily see if these two photos have small distance or not. You basically take each photo and pass it through the network, and then compare the distance of the outputs. And you can decide based on a threshold if they are the same person. This is the approach commonly used in person re-identification. Another way is that given this trained network, you can learn a linear layer or fine-tune the network to do a task of interest. And this is popular in CLIP and Dino and contrastively trained image backbones. Here is an example. We have image 1 of a penguin and image 2 and 3 of dogs. For each image, the network will predict a vector embedding. You can measure the distance between every pair of images using some kind of function. This function can be cosine distance, angular distance, or Euclidean distance. And what you want to find is for the vectors of 2 and 3, they are closer than 1 and 2 and 1 and 3. So to conclude, contrastive learning allows us to learn similarities and differences between different stimuli. This can be useful when the number of classes is not known ahead of time. Currently, most image backbones are trained via contrastive learning. Dino uses image-to-image similarity. CLIP uses image-to-text similarity. So this is very commonly used in machine learning. And good luck on the tutorial.